Hello, everyone. Welcome as usual. Good. So assignment number 3. For the assignment number 3, I am going to ask you to play with patterns. I am going to give you 1 week to do the assignment. So the assignment is going to be due next week, midnight, as usual. So my recommendation is for you to have this done before the exam. Again, the goal of the assignment is for you to be sure that you have the knowledge that you need to complete the exam. However, you can submit the assignment after the exam. The exam is going to be during the lecture time, like right now, and you will still have time to submit the assignment by midnight. So up to you, submit before or after. You're going to have 1 week to do the following. We did an application. We did an application that is going to have four rows. It's a frame in Java. By the way, I am going to describe this. One of my requirements is going to be the only thing that you can use is Java Swing, nothing else, no fancy libraries. So using Java Swing, I am asking you to do an application, and that application is going to be a screen like this one, and that screen is going to be split in 4 rows, and the rows are going to be as follows. 1 to 3 are going to be panels. Those panels are going to be something inside, as you can notice these plots, but they are panels. Just for you to identify the panels, I put different backgrounds, white, light gray, and gray, so you can notice which are the panels. The last row have a bottom. So the last one, this rule, is something that you can click. Yeah, guys, answering the question in the chat, remember, every single class that you take, 3 credits, 10 hours per week. If some class is asking you to work more than 10 hours, talk with your instructors. In our case, we do not have anything for this week. You are studying for the exam. And the reason, because I am asking you to do this assignment now, and I think you can finish this in a lot less than 10 hours, but it can help you for preparing yourself for the exam, to check if you're ready for the exam. So that is the reason, because I do not want to move the due date. Really, the reason for the assignment is for you to study patterns and to review the programming that we have done before. So let's keep this for 1 week. Okay, so moving forward. Guys, can you create a frame in Java, and can you include in that frame 3 panels and 1 JBottom? Can you do this? I need to talk about the details, but use 3 panels, 1 JBottom in 1 frame. Can you do it? Moreover, can you do it, and how many times do you need? And hopefully you can tell me 5 minutes. It is a requirement to use JFrame, yes. And extend, that is a question that I have for you. What do you do with JFrame? You use inheritance, association, composition, aggregation. That is something that we discussed before, right? So there is 1 correct answer, and hopefully you can use that in your assignment. But yes, JFrame is something that you need. JPanel, JBottom. Good. So following that in the chat, that is the idea. So you can do this in 5 minutes, hopefully. Now, the only question that you could have right now, the difficult part, is the things that I am showing inside of the panels. For those things, Hopefully you agree with me with something like this distribution for the step one. Step one, I am asking you to create a program that probably you will agree with me is going to be inheriting from JFrame. Moreover, I am asking you to put here JBottom. So I am going to be using this guy, and hopefully the arrow makes sense. It's going to be a local variable. Moreover, if I want to do something when the user click that one, we're going to need listeners. Which listener for the widget? Hopefully you agree with me that is action listener, and therefore we need to do an implementation. So inheritance, extend, implement, using, and well, I think I am going to use also these three panels because yeah, I am going to have the class panel, and hopefully you agree that what you are going to do is to create a class that inherits from panel, and that is the class that you are going to use in the main. And with this class diagram, with this design that is not new, it's something that we have done before, you're going to create this graphical user interface. Grid layout, or maybe border layout, or some other way to organize the elements, everything in the same size, or going to a different size for the last element, up to you, is not something that I am concerned about it. But more or less, this is your class diagram. More or less, this can be done in 5 minutes in terms of the programming. 10. Yes. Now, this is the important guy. That guy is the one that have those three different versions. For this guy, what can we do in order to create a program like this with this infrastructure at the beginning? There is any pattern that maybe we can use? There are two particular patterns that hopefully you agree with me. One is Decorator. I fully agree. Are you noticing here how these three are kind of similar, but not the same? Similar. Can you remember, like, this here is kind of the original one, and this one here is kind of the original one plus some dots, and this one is kind of the original one plus some dots and some bars. Hopefully we can agree that I am asking you to decorate. In the rows, I put at the end the one that is the core, and I put the decorations, the ones that are decorated above. There is not really a particular order. It's just the original one, simple decoration, double decoration. That is my expectation here. Now, second, second, what I am going to ask you to do is, when I click here, what is going to happen is something is going to create random numbers. Something, some class, some object. Can you follow the idea that if I have someone or something creating random numbers, what I could do is for this to observe the number, for this to observe the number, for this to observe the number? Can I sell you the idea that what I have here, and this is an example that I showed you at the beginning with observer, is the data and the graphical representation should be separated, that The class that is creating the data, the source of the data is going to be one class, and I can have one or more observers. In this case, these panels there are observing the data. With that data, we can plot the numbers. Every single one of these values that are the same that these ones or the same that these ones are basically those random numbers that we observe. And the only thing that is going to happen is, well, we have this one that is observing and just plotting the numbers, connecting a line. We have this one that is doing the same, but also decorating the numbers with the rectangle. And we have this one that is plotting the same numbers, decorating with the rectangle, and also decorating with the gray bars. If I have this idea, this is my graphical user interface. Step number one, could you agree with the following software design? Number one, my graphical user interface, the main that is using the panels. I think that it could be a good idea to create another class. I am calling the class source. That class somehow is the one that is going to be doing the random numbers. That class that is doing the random numbers could be, should be observable. You can use the Java API, the Java util observable. Moreover, my panel, the one that is going to be drawing things, could you imagine that we can make it an observer? So you have the source of information, these random numbers, and you have the panel, the three panels having access to the same numbers. So the three panels are going to plot those numbers. That is the goal of the observer, right? Share information between two classes. Question, what are you going to do in order to make this source create random numbers, like not only one, but one and another and another and another and another? Because the idea with this plot is they are moving, they are receiving information, and you are drawing things. What can I do to have these random numbers running? I click run, and then I start creating random numbers, and they continue and continue and continue and continue and continue. There is not a limit. I have in the chat 200 numbers. Could be more. The numbers should be running as far as the program is running. What can I do? An infinite loop. One problem with the infinite loop is that if you have an infinite loop, your graphical user interface is going to start having issues, because remember, your CPU is going to be running this infinite loop, and if you minimize, maximize, or do something in the graphical interface, probably you are not going to have enough time for that to happen. So yes to the infinite loop, but with something else. The stop button is optional. You can have it if you want. I am not asking for that. The only thing that I am concerned is what we do to have these numbers being generated without having an interference with other activities. And I am just mentioning as an example the graphical user interface. Any of those are options. Probably the only thing that I am asking you to research for your program, the only thing that I cannot be sure that you review in 110 Introduction to Programming with Java, is concurrent activities. What happens when I have one part of my program running numbers randomly, and I have other things like a graphical user interface. If you want two things to happen at the same time, you need concurrency. In order to have concurrency, the easy way in Java is you have this class timer that basically trigger an action every some lapse of time that you define, every second, every 10 milliseconds or whatever. So you can use a class timer. The second option is to use threads. In order to use threads in Java, you can use the interface runnable or you can use the class thread. Not the only way, but three options. Up to you. What is the solution that you provide? My only comment, you're going to put a loop, and if you just put the loop without any of this, or at least this, at least worst case scenario, you can create a loop, an infinite loop, but you need to put inside of the loop a call to this sleep. So the thread that is creating the numbers go to sleep, stop working for a while. And in that period of time, the graphical user interface or other things in the system can happen. So any option, but just be aware that a loop to create numbers is going to have issues with the other parts. Anyway, solving this part and creating the random numbers in a particular class and doing that class observable and doing the panel observer, that's all having the data. The next step, and you told me, these three guys are almost the same. The only thing that I need to do is to decorate them. And hopefully you agree with me in a solution that could be panel is going to be observer, is going to be connected there. Panel is being used by the class main. There are more classes here, I showed you before, but we start with this. Now, in the panel, we're going to put inside these plots. The plots, if we remember the decorator pattern, I am sure that you will agree with me that you need a class that is the original object. This one. We need a class able to draw that. We need a class able to add the dots. Within a class able to add the dots and the bars. This dot and this dot, this bar. In fact, what I need really is a class able to add the bars and a class able to add the dot. When I want the bar and the dot together, what I do is adding the two decorators. These classes, the one with the dot and the one with the bar, need to have a common parent. Do you remember? The decorator part. Moreover, the decorator and the original one, they also need to have a common parent. And this looks like, even though it's in the opposite side, but this is the decorator pattern. I am missing only one thing, one relationship. Do you remember? The decorator is basically a tree with inheritance and one extra relationship between which classes in my example? Yes, composition. Composition between Do you remember? This part of the family have the inheritance, but also the element. The decorators are going to have one drawable. And you can imagine what is going to happen here. It's like, okay, this guy have only the dot, this guy have only the bar, but this guy is the guy doing the lines. And the only thing that I need to do is to have one of these objects in the panel. And just like I did before with the labels and the bottoms and so on, the relationship can be between the plot panel and one of these or several local variables. And if they are going to be local variables, this is the relationship, not the answer. Okay, what is going to happen? That if you remember, this panel have a method paint component. Paint component is the place in which you draw things in the panels. This method paint component receive as a parameter the screen. The only thing that you need to do is to pass this object as a parameter here and maybe as a parameter to all this family. Do you remember the method operation that we described before? Probably operation in this example is going to be draw. You can change the name, but probably this method draw can be a draw that is going to receive this graphic element because everything that I need to draw is in that object. Decorator to create the plots with the numbers that I am observing from another class that is just a generator of numbers. That's it. Your program is going to look something like this. Here, you only need an object from the class simple plot or whatever name you want to use. Here, you're going to have one object from that simple plot decorated with one of the decorators. And in the last one, you have the original, one decoration, a second decoration. And we did this with example with this professor and the mask and other things. Now is a plot. Yeah, remember this one here, the parent. You can use abstract classes, you can use interfaces, depending on the problem. In the Gov patterns, they usually use abstract classes. The implementation in Java, we use interfaces every time that we can. Usually when the abstract class do not have variables and when the methods are always empty, we move to interfaces. So this drawable can be an interface, for instance. The decorator plot need to be a class because we have variables there and we have this one method, the add, and even the update that have a body. We want that body there. So for the decorator plot, probably an abstract class or use a class, but the drawable, that can be an interface. Good. So more or less, this is the structure of classes that you will need. And this is the structure of classes that I could expect you to submit. I am not asking you to use the same names, neither I am asking you to limit yourself to these classes, but I think that this is kind of the minimum, asking about the observer and the decorator pattern. If you add more things like a stop and you go fancy with the multi-threading, I am sure that you're going to have more classes, but the minimum could be something like this. How many hours do you think you need to complete this? We start with 5 minutes with the graphical user interface, but now it's about the threads, it's about the observer, and finally, probably the hardest part is about the decorator and creating something like this. Hopefully it's a couple of hours, no more than a couple of days. But again, start working. It's going to help you to practice for the exam. A lot of questions are going to be related with this capability of creating graphical user interface. You do graphical user interface in some assignments. We're going to ask about it. We're going to ask about the patterns and how to combine the patterns and which are the methods that you need inside of every single of the classes that I described. So hopefully this helps you to prepare yourself for the exam, something that you can complete during the weekend or today, tomorrow. For the assignment, I am asking you to submit two things. I am asking you to submit, obviously, your Java files. I am asking you to use, as I mentioned before, only Java Swing, so no fancy libraries. I am sure that there are a lot of libraries that could help you to do the plots. The core here is not for you to learn how to do these plots in Java. This is just something to do to practice the patterns, Decorator and Observer. Please do not use packages. It is easy for the TA if you submit all your files in one package, in the default package, because in that way we can basically compile and run in the terminal. We do not need to do anything fancy, and it's short, the instruction, right? Just compile everything in this folder instead of going through the different packages. So no packages, all your classes in the default package, in the default folder. That's it. And a class diagram. I am asking you to submit your class diagram. As you notice, what I show you is ideas of what can you have as a class, ideas about how to combine them, some hints about connections that you are going to have. Maybe you agree with my connections, but at the end, I am asking you to submit the class diagram that match your source code. One of the most important things that we're going to review is, okay, this is your source code, and this class diagram, your class diagram, match with your source code. Please do not submit a copy of the class diagram that I just draw. You can watch the video and kind of get the diagram. Do not submit that if your source code do not match that implementation. Remember, what we're doing here is software design, and the most important thing for us is you really are coding what you are designing. If you are doing programming in one line and you submit a class diagram that is a representation of something completely different, you are not getting the idea. So your class diagram hopefully looks like the one that I shared, because that means that you implement what I mentioned. But in any case, your diagram should show what is in your source code. If you show me an aggregation, there should be a global variable in your source code. In your showing me association, only local variables. Inheritance with solid line, extend. Inheritance with dash line, implements, and so on. Things that we reviewed before. Match your code and your diagrams. You submit your diagram. I am asking you for a PDF or an image, whatever is easy for you. And please include the classes that you're using from the API. You can follow the same rules that I usually use. If you're going to use JFrame, it's a class from the library. You do not need to include the variables or the methods for JFrame. It is okay just to put that is JFrame. It is not that there is no methods or not variables. It's just according with the abstraction of my diagram, I am not showing you the methods or the variables in JFrame. Something that you can do also is to use a different color for this box. In my example, you notice blue color or whatever color you prefer, but this one different color, no variables, no methods, because it's a class from the library. For your classes, main, please include all the variables and also all your methods. These classes, the ones that you create, are the ones that should be the big ones in your diagram. They should show everything. And well, obviously, the relationship between the classes. Your main, for sure, as you mentioned in the chat before, is going to be doing inheritance. It's going to be doing inheritance from JFrame. JFrame can be empty, but your class with the main have everything. So someone reading your class diagram is going to know what could be found in your source code. And that is your assignment. Any question, guys? Very good question. My recommendation, and usually something that happens, if you have a class and inside of that class you are using a collection like a vector, a linked list, or so on, usually what you do is to put that here. It's a data structure. For the data structures, usually you do not do this. I have a class, and my class have no. Yeah, list is a class. Yes, you have a relationship with the class. It's the data. To show the data, you use attributes and you put the attribute there. And that is going to make a space, because instead of this relationship that is kind of trivial, you're going to be able to show other relationships that are more important. Remember, a class diagram is an abstraction. And when you create an abstraction, you are the ones that select which are the important elements that you want to make part of the abstraction. Abstraction is hiding the things that are irrelevant, showing the things that are important for the reader. So my recommendation for any data structure, a tree, a vector, a linked list, arrays, you put the thing there. Is okay, I have elements and those elements are in a vector or in a linked list or whatever. No need to show the relationship. Good. And you are going to need vectors in our example here. As you can imagine, in order to draw those dots, what is happening is you are adding values to a vector, to a repository. And the only thing that happens is that when you draw, you are drawing all those elements that you have in this vector or repository. The plot is drawing not what is happening in the class with the data, but what you have stored in a local data structure that could be a vector or a linked list. And you can show that in panel, use as an attribute. Good. Any other question, guys? This should be the behavior of your program. So if your program behaves like that, if you are able to run your program and as you notice, just connect the dots, and when you have the full screen, it just delete the oldest values, which make this animation thing. So that is what we expect when we run your program. Javadoc, very good question. My recommendation, guys, use as something that you should do always. Put Javadoc for the classes and Javadoc for your methods, just because that helps you later to create the API. So a short Javadoc for the method and for the classes, nothing fancy. Oh, please ignore the red line. The red line is the average of the values. So basically the line is showing me which is the average. It's moving according with new values. My goal was to include another pattern to calculate that average. I am not doing that just because of the exam, so you can ignore the red line. Yeah, this bottom is all this space. Again, it is not the most important thing, but what I used here was a grid layout. And as you remember, it's going to split the screen in cells that are the same size. So in this particular case, I split in 4 rows, 1 column. So what I have is 4 spaces that are exactly the same size. So this big J bottom is the same size that my panels. So I can click in any place because I have a really big J bottom. Good. But if you want to make it this smaller, it is fine. The important thing, the patterns here. Good. Any other question, guys? The rule is only one time. Sorry for the animation here, but it's only one time. It's only one click. I make one click here, and when I make the click, the numbers start running. It's not like I am clicking several times. That is the reason because you need the thread to create the numbers. This guy is an animation, so it's like doing this, but it's not the idea. It's one click. Good. Okay, so guys, see you next week. Thank you.